I mean, if I'm not driving the slides, I can. Do you want to drive the slides, or should I drive the slides?
Okay, I can drive the slides.
Okay, I'll pick my driver client up. It's good to have somebody who reminds me in case I miss something.
Oh, oops.
Yeah. Yeah, I don't. I usually try to list all of. Was my water? I usually try to list all of Rye as, or all of X Rye as a conflict, but I think I missed that one. I don't.
But it's a Windows. How to put it in Launch?
Should be there. Those should all be PDFs. So, I mean, I've got the PowerPoints, original PowerPoints for two of them on here, but I don't know if. What browser? IE?
Yes.
Go back. I mean, I can't read Chinese, but if you go to the page, download rather than.
Download it. Okay.
Yeah, download rather than. And then it should be. Probably open with. Oops, that's interesting. Do I not have electricity in there, or has my?
The power say.
What? Oh, there's power there too. There we are.
Okay, got it.
Okay. Don't yet seem to have the meeting queue up. Let's wait till that noise. Let's wait till that noise passes, whatever that is. So it's 5:34, which I think is supposed to be our start time. We don't have a terribly full agenda, so we can give people a few minutes to trickle in. But yes, we don't have a terribly full agenda, so we give people a few minutes to trickle in, but probably get started. Welcome to Avtext in Buenos Aires. Hopefully you knew you're in Buenos Aires. Hopefully you knew you're in Avtext. Thank you for not deciding to go to Modern. We'll have fun. So, all right, let's go next slide. Okay, we have Ronnie taking notes. A second note taker would not go amiss if anybody wants to volunteer. And I can keep an eye on the Jabber room if need be, but if anybody else can pop into the Jabber room, would probably be appreciated. Adam, I know I've seen you use a Jabber client before. Oh, that's right. Yeah, that's a bad idea. I'll keep an eye on Jabber, and if other people feel like joining and yell at me if I need to say something. Blue sheet should be circulating. Hopefully you've used one before. If not, ask the person next to you. We have a Meetico. We have several people in the Meetico. So hopefully we'll be getting some remote participation, and hopefully we'll even get the remote queue up at some point, which we don't seem to have yet. I've let the Meetico team know, hopefully. Or maybe I need to poke something here, I don't know. Probably not. And I have my big red button just in case. So, next slide. Oh, something's happening here. That was good. Excellent, excellent, good. So yes, we have several remote participants, so hopefully they can talk to us if they have anything interesting to say. Note well, note it well, note all the wells. You've probably seen this before. If not, welcome to IETF. Next slide. Okay, our agenda. By the way, I'm doing all the talking. Do you want to do any talking or? Okay. Okay, sure.
Okay, here's the agenda we're going through today. Agenda BOSH and the status updates we're doing now. And we totally have 4 topics today. Firstly, we'll look into the feedback requirements from CAT. We put it in the beginning because our presenter has a very tight schedule. After that, Adam will give an introduction rate, mostly about the decisions on the side meeting on Tuesday. And then Mo give an introduction of frame marking RTP header extension. And the last one is codec control messages for layered codecs. And in the end of the meeting, we probably have open mic and may discuss some other business if there's any. Okay. Here's a status of the documents in Avtext. We have published 2 RFCs since last Yokohama meeting. RTP taxonomy has been published as RFC 7656 in November last year, and RTP pause and resume has been published as RFC 7728 in February this year.
Do we know what that beeping is? Where is that coming from? There's a loud beeping noise. Is that? Oh well. Okay. Okay. Okay.
So we still have 3 working group documents that will not be discussed today. ERA document is stable now and probably ready for working group last call. So if no one gets it, we probably do it after this IETF meeting.
So I want to, John, as the author of that, I had one side meeting with Mo about some stuff. We're going to align some of the formats between that and the frame marking. But other than that, I think that's fully technically complete. I mean, Rachel obviously is going to be running the last call since I'm an author, but we want to wait until all of the RID stuff is done, so it's not to be doing more than one thing at a time. So once RID is done and pubrect, we will probably start a working group last call on that.
Yeah, and SDS header extension is now in ISG review and it's going very well.
Yeah.
And
I don't know. Is there anything to say about that SDS header X, or you just Ben, or is it all good? The SDS header extension. Anything good?
SDS.
Anything is there? I don't think there are any issues there, but just to. Okay. I don't think. Is that mic on, by the way? I mean,
No.
Is there a switch on it? Okay.
Oh, it's good.
So yeah, okay. We're good now. Magnus, you have something to say?
So that's the header extension. It's on the agenda for the 5th of May.
Okay.
Everything needs to go forward.
Okay. Sounds good.
Yes, as for the splicing draft, version 6 has been recently submitted to address issues from INA review made by Magnus. And I think it's waiting for Agnes' feedback. And after that, we'll maybe go to the ISG.
Okay. What did you say? Oh, was Rachel wasn't or I wasn't? Make sure. Oh yes, that's okay. Okay. Yeah, we will try to speak right into the microphone and speak loud, and so they'll complain about us instead of us complaining about them. So, yeah. So, yeah, but you guys, you finished. You're the author on that, so you finished saying.
Yes. Do you need I to repeat that?
Did everybody hear what Rachel just said, or? So I think Magnus had a comment, so was the expert. So.
Yeah, Magnus was. Yeah, I promise to review the changes. I haven't done that yet, but I've tried to get it done soon. Hopefully by tomorrow, no later by tomorrow. So.
Okay, good.
So that's the end of.
That's the end of the chair slides. So, so anybody have any issues before we start the first presentation? All right. So,
Go to the first
yeah, the RMCAT feedback requirements. No, not that one. That one. You can come up anyway. You don't have to wait for us to find your slides before. Okay. Okay. Yeah. Is that live? I'm not sure. Is there a switch on it? Make sure there's a lights on. There's a red light. It's red. Is that good? They're bad. And there's definitely nothing there. We'll flip the switch, see what happens, and then. No. All right. Grab the floor mic, I guess.
Yes.
Not a good AV day.
Hello. Yeah, works. Okay. So my name is Jahid. I'm here to present an update on what happened in RMCAT working group. I think you guys already know, or there has been a presentation here before in a last IETF meeting, and there was some critique. So the task for RMCAT was to go back and see like what are the requirements for different condition control candidates have, and come up with something that we can match and see like if we can have some generic feedback messages or not. And the generic feedback message was mostly because of you want to have interoperability and regular of condition control. Next slide. So since last IETF, what this RMCAT group did is to call for the authors or the algorithm designers to come up with what are the requirements for their respective algorithms. And so we summarize that up, and then this IETF meeting, we decided we'll have a design team that will go through and analyze the requirements from different candidates and try to see like, okay, if we can have a generic format or not. So the message here from what I want to convey here is like, there will be a design team. If you're interested, please join there. Yeah. So I'll go through the couple of requirements. Yeah. And that
just to amplify on that, I feel like it would be useful to have RTP expertise on this design team early. So certainly, if we could get somebody, obviously contact speaker directly, but anybody who's willing to do that,
that would be really nice.
Especially some colleagues at the same company as him, Magnus and
Yeah, I think that would be really great. I mean, we have some experts on RTP, but I mean, you guys are more. This is what you do. So, and this is about an RTCP extension we're thinking about. So, guidance, expertise that will help us. So next slide. So let me just go quickly. What are the requirements we have? We have an algorithm called NADA, and the feedback requirements are an adaptive rate mode. So the rate mode is like the algorithm will behave a bit slightly different in the beginning, in the startup and steady state. So the receiver telling me whether it's a steady state or startup. Is it that's the current? Yeah, okay, good. And then I think the NADA algorithm that actually summarizes lots of condition indications, like, and then basically the receiver now currently doing the signal condition signal aggregation. So you like to send that to the sender back, and of course it wants the receiving rate, currently receiving rate. And we this brought up one thing, and because I think last time it was also discussed, like whether ARMCAT solution will be sender-based or receiver-based. I think it was pretty clear, like we need, if we think about this generic feedback, it is better to have something in the sender. So I think it is almost decided, like every solution ARMCAT will have a sender-based adaptation. So that also means like NADA will calculate this kind of information from the feedback the receiver will send.
We have some feedback from the Jabber room.
Yep.
First, both Colin Perkins and Randall Jessup say Colin says he's happy to join the design team. Randall says he can also help out some. So
great.
Yeah, and then Varun Singh asks, is our mode a single bit of information?
Yes.
Okay.
Yeah. Okay, and also we need to look into the feedback interval. It's recommended is 100 milliseconds, but you need to read and look into the ARMCAT presentations to know more about it. So next slide, please. Then we have GCC proposed by Google that also have a different kind of requirements when it's like in startup phase and condition control phase, that is steady state phase. And then they also another requirement is like they would like to have to know about the bundling on the stream, like if they can do a aggregated condition control on those kind of distributed. Next slide. So if we look into what they really need packet identifier, packet send time, packet arrival time, packet size. So if you can see here, the packet send time and packet size is already in the sender because we're talking about sender-based algorithm. So basically from receiver, you need the packet identifier. I think last time the proposal was like you have a new sequence number, it's like transport agnostic, but I think it would be also there. It could be also done by SSRC RTP sequence tuple. So that's the current idea. Next slide, please. And for Scream, it has two kind of requirements. One is like functionality, and one is enhancement. So basically, Scream needs arrival time stamp because it's kind of like clock-based algorithm, but it still you'd like to calculate the rate and stuff, and list of received packets so that we can identify losses and stuff like that. And then we have some two optionals like a ECN counter or a counter C value and a source queen speed to force the sender to reduce, like if you want to really force the sender to reduce certain bit rate or something. So next slide.
We have another comment from Jabber. Varun Singh asks, has anyone considered piggybacking this information on RTP header extensions instead of RTCP?
We did. We did mean Scream actually is thought about it. That should be same there. But but I think RTCP feedback message would be a better option than RTP extension.
But if it's from receiver to sender, then it needs to be bidirectional RTP because typically RTP is unidirectional.
I didn't get that. Receiver to sender.
If the information is coming from the receiver to the sender, then you need bidirectional RTP because RTP is unidirectional.
Yeah, sure.
Yeah. I agree.
Yeah. Next slide, please.
Jonathan. Oh yeah, and we have Randall.
Randall is there.
I get to hit the big red button. Ooh, exciting!
Hopefully, we're still alive.
Yeah.
Hi. So,
Where are you?
it's a echo from the room, but that's okay. I wrote the requirements for ARMCAT, and there was actually discussion of the possibility of where possible, feasible, of putting the feedback on traffic going in the opposite direction. Obviously, as Ronnie indicated, it only is it possible if there is traffic going the opposite direction, and the traffic going the opposite direction may not be going out for a while. So it is only dropping in the header extension or something is handy for cutting your number of packets you're sending, but you don't want to wait necessarily 30 or 50 or 100 milliseconds to do it. If you have a packet ready to go out in the scheduler, it may make more sense though to drop it in a header extension than to send an entirely separate packet. So it may be an opportunistic way to cut the number of packets and bits sent.
Yeah, that is the case actually. I think in the RMCAT design team, when there was a design team, we discussed all of the things, and I don't see like the conclusion at that time. We discussed about these kind of things, and there was no conclusion like we should use RTP extension. So that's why perhaps at least for me, it's strip from my list of options. So conclusion. The authors of Scream draft said like, okay, what Scream need could be realized by the RFC 3611 and the ECN we have RFC 6699, but I mean, a future compact format will be useful. So there might be, this might be good. Next slide, please. So we have another one, shared bottleneck detection. I mean, the difference between this one and other one is it also needs some statistical data that is gathering from different links and try to see like whether it can actually detect the shared bottleneck or not. If these things have to be done in the sender, then basically that statistical information needs to be sent back. And it is like there is no frequency requirement too hard on it, because I mean, if you send regular data, you will get better efficiency on finding out the shared bottleneck. If it is not, then you'll just get delayed. Yeah, but still, I think the requirement value has a 350 millisecond interval. Next slide, please. So if we summarize everything on one slide, so this is what we need for NADA. I think we need to decompose it a bit to see like what are the information the receiver need to send to sender so that this can be calculated. For GCC, you have a packet identifier, maybe not really related loss, but kind of loss. But you need packet arrival time, stream packet arrival time, and list of RTP packets. So you can see like these packet. So you can see like there are similarities there between GCC and stream. And obviously SBD, you can relate this to other two, and only difference is like they want to have some statistical information back. So if you look into this one from very like we roughly did that. So there is the conclusion in the RMCAT draft, RMCAT working group was like, okay, if it looks like this, we can work on it and try to see whether we can really generalize the format and everything. And that's why the design team was proposed. So we'll be working on
Before Mo goes, I have another.
analyzing these kind of requirements.
I have a question from the Java room before Mo. Varun asks, does SBD need data from SSRCs outside the scope of the RTP session?
I don't know. You asked the author about that one.
Mosinati. So I'll echo what I said in the RMCAT session, which is it's good to look at this from the RMCAT perspective of bandwidth estimation. But I think we as AVT groups need to look at it from the holistic perspective of both media repair and congestion control. And it seems like the common thread, the most critical thing out of all of these is the need for ACK level info. I'm ACKing this sequence number and I'm giving you the arrival times of the inner arrival times of that packet. No. And so with those two bits of information, I think you cover, a majority of what all these candidates need. And that's also what we need for media repair. So I think we need to look at it more holistically and figure out, are there already good XR blocks that we can use for ACK level information? And are they efficient enough for very high frequency use, or do we need to, create something new?
Okay. Yeah. those kind of input I expect from this group, actually.
Xiaoqing, one quick clarification. I think the first annotation probably means can be calculated from per packet information, like
Okay, you,
sort of
I mean, I have
basically
not,
for the NADA
the-
solution. Yeah.
yeah,
Okay. And then that's just for people who only sees the slides later. And secondly, in terms of what we want to figure out in coming up with the common feedback requirements, and just want to maybe clarify that it's not just a common format of information, but also at least the recommended or the sort of the required feedback interval, how fast things are.
so next slide, please. So we also looked into like what are the frequency requirement, because this is also one of the things that you might want to discuss, like how frequent you need, and can you generalize, have a mean frequency or something like that, or what happens the one algorithm needs 50 millisecond, one algorithm is fine with 100 millisecond. How do you do that? So one simple solution would be to negotiate such kind of things, because this is one of the reason here is the interoperability. That also means like you can have running one algorithm in one direction, another algorithm in another direction. So you can do some negotiation and the session setup and do different kind of frequency and different link. So this kind of things we are talking about. So these are the information that so far we have collected. We're going to analyze that one and try to see like how you converge to a common format and common kind of think more hard about what to do with different frequency and stuff like that. So that's it. So this work design team, I don't think it will be a long design team. We're talking about something in between next IETF meeting. So that'd be great if you can join and help us.
No, again, just to echo another thing from the ARMCAT session is that these fixed feedback intervals, I was objecting to, having the ARMCAT candidates using fixed intervals rather than something scalable with RTT times. So maybe as the RTP groups look at it in more detail and look at applications of RTP that are, more sensitive to RTTs, especially for media repair and things like that, maybe we can arrive at some solution candidate proposals that don't use fixed intervals like that.
Yeah, I mean, we have RTCP bandwidth from the session bandwidth, and we don't want to use the whole bandwidth only for congestion control so that we don't get another information. There are other RTCP, but I mean, here, even if, I mean, you see the range here, so 20 to 400 milliseconds. There are already range. It's like we're not talking about a fixed value. It can work. We're saying like, okay, just to help implementers to, if we can come with a like minimum frequency or something like that, that solves every problem. And then basically every algorithm will have its performance degradation, or I mean, in one of the algorithms that show like if the frequency goes up, only thing is like your bit rate will go down. So something like that. It's not. I don't think like any of the algorithm is going to break down if it is not a absolute interval, and it will be randomized interval. I mean, this is RTCP. You'll have a randomization in the interval. So we're not talking about absolute value, but what we need to do just to think about like what is the best way to solve it, because as you see, they have different frequency here.
Okay. So Varun Singh in the chat room says he's also interested in contributing to this. So.
Sorry?
Varun Singh says he's also interested in contributing to this. So
okay.
So he can, yeah. So basically, yeah. Context ahead for. I'm pronouncing your name right?
Right?
I'm pronouncing your name correctly. Is ahead?
Yeah.
Okay. So context ahead if you want to join the design team.
Any more question? Feedback?
Actually, one thing as an individual, I'll go to the floor, Mike.
Sure.
Jonathan Lennox is an individual. One thing that I feel like we will need to figure out at some point is, obviously the RTCP bandwidth itself, which is usually a fraction of the RTP bandwidth. So we're going to need to figure out, as these algorithms find out how much bandwidth to use, what we want to do about the RTCP bandwidths, especially as these are running, these are each running independently in the two directions. And so I think that's going to be a big, complicated question for RTP at some point. And I don't really know what to do about it.
I agree with that. I have I have heard about that, and there was lots of, yeah, I have my issues with this. But anyway, so now we know, this working group knows, and I hope we'll see some of the known page in our design team. Thank you.
Thank you.
Thank you.
Yeah, that's what. And Adam Roach is up next with
If that works.
the header extension formerly called grid.
Formerly called written, yes. Hi, okay, so as you know, we were going to split off the RID portion that's going in RTP and RTCP into its own individual draft, so it wasn't in MMusic anymore. And we had some comments come in, and we discussed them, and then we had a whole bunch of other comments come in. Basically, we ended up with some comments during the working group last call where the fact that we had basically identifiers in a way that was kind of tailored for what we wanted to do in WebRTC gave people heartburn. And so it wasn't the first time we'd heard these concerns. So we kind of sat down and tried to work through what everyone thought would be a good way to move forward with this. And so we came up with something I think everyone can live with, and that's what I'm going to present here. And if everyone's happy with it, I'll go ahead and reorganize the draft like this, and we can run it through another last call, hopefully. So go ahead and go on to the next slide. So the general changes have been that we've given these things, we still have two RTCP types that can be put in RTP extension headers, and we've given them new names and new purposes in life. The first one is now RTP stream ID, which is unique per RTP stream. It's basically for any given, thing that would be pointed at by an SSRC effectively, modulo changes in SSRCs because of collisions. This would point to that. And then we also have a second item that if this is a repair stream, it can say, and this over here is the stream that I'm repairing by pointing to its RTP stream ID. So these are kind of new names, kind of unique to this draft. Okay, so go ahead and go on. Yeah?
Question from Varun is, should flexible FAC need to know about this?
I don't know. I'm going to look around, see if Justin or Peter are in the room.
I mean,
Does Flexible FAC need to know about this?
as an individual, my reaction response would be no, because FlexFAC has SSRCs in it. This is more for RTX, but I will let other people say their opinions too.
Right. If everything were flex spec and we didn't have normal FEC and RTX, we wouldn't need any of this.
Okay.
No, I agree. I think this is more for legacy FEC. So current, oh, sorry, Mosinati. The previous generations of FEC don't have SSRC bindings, so I think it'd be relevant for them. For FlexFEC, we wouldn't need another binding.
So Varun comments that FlexFAC does have RTX covered. Which is to say, again, speaking for myself, that you can, an RTX is a retroactive FEC of a single packet.
So again,
It does have a higher header
So again,
overhead than 4580.
the new FlexFEC way of doing it, we don't need this. So new FlexFEC can do retransmission in, different FEC codes with just pure SSRC binding. It doesn't need this. But the old RTX and the old FEC codes don't have any kind of SSRC binding, so they would need something like this for association or SDP association, if not RTP association.
Okay.
Peter Thatcher.
Peter, yeah, go ahead.
So in some future day, when everybody does flex spec and nobody does FEC or RTX, we won't need this anymore. Except for maybe as part of the simulcast with RID.
And you'll be happy with that then? You'll have to look in a couple different places to try to figure out what streams are affiliated with each other?
Well, with FlexFEC, you already know what stream it's affiliated with because FlexFEC includes it in the paper.
So Varun asks again, how would older retransmission use this? As in, are we expecting them to change their implementation? And again, answering him as me, I would say not if they're not already doing simulcast. If they're doing simulcast or anything else that needs the header extension formerly called RID, then they need this, but that's a new implementation.
That sounds about right to me.
What?
That sounds about right to me.
I think that there were issues before with RTX and FEC when using with the SDP anyhow. Then we needed some solution. We're looking for solution. If you want to use the old one, you may need to use this anyhow.
Mo, again, I think the general solution that was come up with, I don't think it was really tied to just repair streams. I don't think repair streams by themselves would have been enough to force us into this new general solution. I think the idea was that there may be new things that we come up with that need this new general solution. And oh, by the way, it also works for repair streams, even though we might not actually need it for the new kinds of FEC and new kinds of repair that we're thinking about. It works for the older kinds of FEC and older kinds of repair. So let's just go ahead and spec it out for those as well. I mean, it will work for the repair streams, especially for current, 4588 RTX and current, I forget what the numbers are, 5109 or whatever FEC. It'll work fine for those, and it's useful for those. It's not harmful for the new Flex FEC. It's just not necessary because we have other bindings. We have direct SRC bindings. So.
Okay. All right. So here's where I kind of show what the changes imply regarding these streams as they used to be in the old plan, as they are in the new plan. This is kind of an eye chart, so it's probably not worth necessarily going through it in this form. But I do want to point out I've basically taken RID 1 and made it red, RID 2 and make it blue, so you can sort of correlate these to each other, because we're going to split it apart and look at them individually. So on to the next one. So here we have basically a video codec and 3 types of basically repair streams associated with it. And we're going to have 2 different RIDs, which is now just an SDP construct, as it doesn't appear in the RTP or RTCP directly, that restrict these in certain ways and point to the specific streams that they're affiliated with, in particular the non-repair streams, and then the repaired streams are attached to those using their, what's the new thing? Repaired RTP stream ID, right. Okay, so let's go on to the next slide. Now, so technically, I say there's no change, so I go back one real quick. The footnote here, there is actually going to be one more RTP extension header mapping, because we now have to use 2 RTP header extensions even in like the WebRTC case, but that's really just an SDP change. It doesn't really impact much of anything else. Okay, next. So looking more closely at what happens to the actual streams. So you have the actual non-repair stream, which has the RID, used to have the RID associated with it, and then all of its repair streams would have the same RID. And if you wanted to indicate them individually, you could add this RRID thing onto it that sort of differentiated among them, which would not be used by WebRTC, but it was added so that things could be uniquely identified. And this was actually a solution that had some objection to it as being somewhat inelegant. And we've moved it now to everything has semantically its own stream ID. Now, for WebRTC, we don't need to add an explicit stream ID to the repair streams because we're not ever going to refer to them, but if you wanted to, you could. And then the repair streams can also have this pointer to the stream that they repair. So in this case, we've got a RID of 2, points to the RTP stream ID of 2, and any repair streams with an repaired RTP stream ID of 2. Does that make sense?
Just Colin Jennings. I'm just thinking about this last comment here. If the VP8 stream and the repair stream were both sent on the same payload type, then would you use that? Would that RID 7 be used to demux the 2?
Is the same PT, same SSRC?
But SSRC isn't. Let's say SSRC wasn't signaled.
SSRC was
Not signaled.
not signaled, right? But would it be the same stream? I mean, if I looked at this on the wire, would it be the same sequence of packets, or are these coming across as different SSRCs?
I don't even know what that means. They're on the same ports.
They need to be 3 different.
Yeah, I think they're 2 different SSRCs.
Yeah, that's fine. So yeah, the non-repair stream would have a RTP stream ID,
Right.
and the repair stream would have a repaired RTP stream ID pointing to that same number.
With a different SSRC.
Right.
And that will happen in all the repairs we're using. They'll be different. Yeah. Okay, thanks.
Okay, going on to the next one. So implications on work in other working groups, because we're going to have to take this and sort of spread it out a little bit. For MMusic, the ARID lines are going to have to say, instead of containing RIDs as defined in this other document over here, we're going to say they contain RTP stream IDs, and we probably have to backronym RID to mean something else because we don't want to go and change it all the way up to like the WebRTC API spec. It's easier to keep calling it RID. The simulcast draft itself shouldn't need to change. It just refers to the RID draft and should be able to just keep going the way that it is. For W3C WebRTC, I'm not even certain there's a language change necessary here, but just semantically, the RID parameter on RTP encoding parameters is going to point to the same thing as A equals RID in SDP does, which is to say this RTP stream ID in the non-repair streams and the repaired RTP stream ID in the repair streams. And then, right, for RID simulcast WebRTC use, this means that the source RTP stream and the redundancy RTP streams now use two different header extensions from each other. But this is very easy to correlate. Okay, so that's it. As administrative work, assuming we accept these changes, I still plan to call this AVTX RID just because that's the easier thing to do instead of starting over with a 0 and all that fun stuff, unless someone really wants to raise a stink about it. So it's not going to say anything about RID at all anymore in this document. That's just going to be his name. Okay, good. I see some vigorous nods.
Yes, I'm pretty sure draft names are between the editor and the chair, and I don't want to change it, and neither do you.
Excellent. Okay. So as a path forward, assuming that everyone here is okay with this change, then I intend to go ahead and make these changes in the next few weeks to the document. And I think we'll probably need to go through another working group last call because the changes are relatively large and structural. I mean, relative for a 4-page document. And then if things go well, I'll try to get this in front of the IESG really soon, definitely well before we end up in Berlin. Sound good? Everyone, are we all happy? I see a thumbs up.
Okay.
I see a few thumbs up. All right, I'm done. Thank you.
Thank you. All right, good. May all our documents have consensus that easily. And Mo, you're up.
Okay, we're going to talk about the video frame marking header extension. And this is the second rev of the work group draft. To reiterate the purpose of this, the work is for mostly for RTP switching in a payload agnostic sense. And the first motivation is if the payload is encrypted, then you can avoid decryption costs by using this header extension to basically mirror some of the things that would be in payload headers, mirror them into RTP headers that are in the clear. And more importantly than decryption cost, there's some architectures like PERC where the payload will not be able to be decrypted unless you have the end-to-end keys. And in general, these switches will not have the end-to-end keys. And so they won't be able to operate on any payload headers. They must operate on only in the clear RTP header extensions. And then finally, even without looking at the encryption aspects, there's a motivation to be able to deploy switches that can operate even with new codecs that are being developed. So for example, a main or switch that's deployed today could conceivably be usable with NetVC's final codec, even though that probably won't be finalized for well into the future. And you could do this payload agnostic switching by having these normalized header extensions that normalize the behavior of the switch. Next slide, please. There's also a few more benefits when you do this. You're able to do smarter switching. So independent of the encryption and payload agnostic benefits, you're able to switch cleanly at IDR boundaries. So when you have active speaker switching, you wouldn't necessarily need to forward any unnecessary packets, and you'd have very clean switching at speaker boundaries. You can also use this to do congestion control more intelligently. You can drop packets that you know are less important because importance is part of the things encoded in the header extension. And you can also drop certain layers towards endpoints that can't handle those layers. So this is not for congestion control, but for capability control. The device may not be capable of certain fidelities, so you can drop those fidelities toward it. And then not just for the switch, but for the endpoints, there's also some benefits. Being able to do better recovery. You can know better what things were lost and take better actions based on that. Next slide. So this is the extension. It's a very simple 2-byte extension. Some frame flags in the first byte, start a frame, end a frame, whether something is independent or not. That's typically an iframe, IDR frame, or keyframe in VPX parlance. Whether it's discardable or not. So if nothing depends on it, it's discardable. Useful for congestion control. Base layer sync, I'll talk about that in a little bit more detail for one of the open issues. And then the temporal layer ID, TID, and the spatial and quality layer ID, LID. So that's the entire extension. And in the last meeting, we agreed to add LID as a mandatory part of the extension. Next slide, please. These are the layer mappings for all of the different codecs in the current draft. We included all popular modern codecs. If anything's missing, please let us know, and we'll be happy to add the mapping for that codec. So far, these are the only ones that we felt were relevant for current switches and endpoints. That's fine. Next slide. Okay, so now on to the open issue. This is really what we wanted to talk about today. There was in the last meeting, there was a proposal to add TL0 pick index to this extension. And so we started looking at that and looking at the issues around it, when it's useful, when it's not. And we had some discussions, and I think we want to continue some of those discussions now. So to give people some background, what is TL0 pick index? It's something that was really born out of the H.264 SVC payload format, and it also exists in the VP8 payload format. It's the temporal layer 0 picture index. And the temporal layer 0 is when the TID is equal to 0. So that's the base layer of the whole stream, sort of the foundation of the whole stream. And when you're in that base layer, when you're in TID equals 0, you just simply count all the frames up. It's a running index of those frames. So it's a frame identifier for the base layer. And if the TID is greater than 0, you're in one of the enhancement layers or non-base layers, then it's not identifying that frame. It's actually pointing to what TID 0 frame it depends on. So it expresses a dependency when TID is greater than 0. So again, when TID is equal to 0 and you're in the base layer, it's identifying itself. And when TID is greater than 0, you're in an enhancement layer, it's identifying the dependency on what frame in the TID 0 layer this current frame depends on. Now, what's the purpose of this? Why would you bother including it? The main use is that during frame loss events, when you're trying to recover, you can figure out whether or not the dependency chain has been restored. So once you have a frame loss and then you start forwarding frames again, you can decide whether or not the receiver would have all the dependencies required to render the stream. So the main can intelligently switch things only when there's a full dependency chain, and the endpoints can intelligently render only when there's a fully met dependency chain. Next slide. First, is there any clarification people want on what the TL0 is or used for? Wasn't sure if anybody actually knew about it. Okay, so on to the issues of using it for this header extension. So first of all, it depends on how the RTP stream is packetized, whether it's using MRMT or MRST, where you have you're using different SSRCs for each of the layers, So if you're packetizing it, if you're packetizing a scalable stream into a scalable encoded stream into multiple RTP streams, each RTP stream containing one layer, then we don't believe that TL0 pick index provides any value because the base layer itself is all on its own in a separate RTP stream. So any loss in the base layer is trivially detected just by sequence number. There's no ambiguity about whether or not the losses were in base layers or not. So sequence number gaps should be all you need in the MRMT and MRST cases. No disagreement.
That part I agree with.
Okay,
yes.
so Jonathan's going to disagree with some things. I'll let him disagree in line or at the end, whatever he
Yeah,
wants to do.
well,
Okay, so the more nuanced case is SRST, where you packetize the scalable stream all in one single RTP stream, basically muxing all the layers into a single SSRC. So different packets of that single stream could potentially be different layers. There's a little bit more fun. So if you have frame loss in the base layer, and you're doing a very simple encoding with a fixed regular frame rate and a fixed regular GOP. GOP is a frame structure. So you're doing, let's say, temporal scalability with 30 hertz and 60 hertz. So you're sending every other frame is an enhancement frame, and every other frame is a base layer frame. So you have 30 hertz of base layer frames, and you have another 30 hertz that brings it up to 60 hertz of enhancement layer frames. Simple, regular GOPs like that, simple, regular scalability structures with fixed frame rates. In those cases, the RTP timestamp is usually enough information to infer whether or not losses were in the base layer or the enhancement layer. And so again, it probably obviates the need for TL0 pick index. Now, when you get to more complicated cases where the GOP could be variable, so you might not have a fixed hierarchy of temporal layers, then VP9 calls this flexible mode. Then the TL0 pick index may be useful because you can't infer based on timestamp what the relation of the layers are. But it's important to realize that if you're in these complex variable GOPs, there's probably also a likelihood that there's more complex encoding happening, and that complex encoding might not be expressible with a simple single dependency like TL0 pick index implies. So the recommendation from the authors was that the cases where TL0 pick index may be useful are marginal enough that it's probably not worth including as a part of this extension. And if some applications would like to use it for those very marginal cases, maybe we should have another extension that adds TL0 pick index on its own. So after some discussion with Jonathan, he arrives at a different view.
Yes, so
I'm sure he'll share.
Jonathan, thanks. I'm going to speak as an individual, but stay here in case anybody in the Jabber room also wants to comment anything. So on the timestamp point, I find that, so we have found that in practice, cameras don't produce consistent frame rates even if you ask them to. Between various automatic exposure adjustments and even things like, CPU load or, USB bus load, you often get frame rates sort of slowing down and speeding up unexpectedly. So, you could probably have, you might be able to have reasonable heuristics that work most of the time based on timestamps, but there's plenty of times when you'll incorrectly think that something is not a, that you'll misinterpret things. And then on the second point, the fact that there might be on the variable, in the variable cases, that there might be, the fact that there might not be a single TL0 isn't really that important, because what the important thing is, what is the most recent TL0 you depend on? That TL0 probably itself depends on the previous TL0, and that one depends on the previous TL0 all the way back to the most recent iframe. So really, really what you need is, do I have the complete set of state from the most recent, the complete long-term state from the most recent iframe till now to decode this? What the structure is doesn't really need to be described here. It's just, do I have the full state?
Right, but that's where I would disagree, that if you're going into complex encoding, I don't think just having a base layer frame as your only pointer is sufficient anymore. You may be pointing to the prior same layer frame, TL1, maybe
Yeah.
pointing to a TL1 frame as a bipredictor along with a TL0 frame. And so in those cases, we don't have a TL1 pick index
Yeah,
that
I
we're,
mean, so you'll need
that we're
this-
signaling.
Yeah, so in that case, you might need a B. You might rely on your B bit whatever as well. But that's so yeah. Oh yeah. So Bernard is going to talk. Well, first I'm gonna. I guess Bernard will say what he wanted to say, but Randall also says Linux +1, so I wanted to get that in there.
So with respect to Jonathan's point about variability, that happens all the time in screen sharing to a rather extreme degree. And so I don't believe that the timestamps by themselves can always just tell you what layer you're talking about, because the base layer might vary in its frame rate in quite extreme manner. And also, when you talk about complex encodings, there are encodings that are easily expressed, such as hierarchical encodings, like what IMTC has done. So that I don't believe, and those are just for temporal, for which TL0 pick index is sufficient. So I don't buy that argument either.
Stefan?
So
Are you just lurking, Stefan, or are you actually going to say something?
I want to say
Oh
something.
no, Bernard's.
are you done, Bernard?
Bernard, are you done? Because you're still showing us talking.
Maybe mute your mic if you're done, because maybe getting some noise or static.
Okay. Right. I think this will let Randall talk. Yes. Good.
Hi, I'm going to say +1 to what Jonathan said, and also in addition to what Bernard said about screen sharing being a source of very random frame rates, the code that's leading to the encoder may decide to drop frames and therefore cause gaps in the frame sequence, as well as the camera itself adjusting due to light levels and all sorts of other things that were mentioned.
Yeah, Randall said that. I want to amplify that. In today's encoders, it's quite common and quite often that the encoder decides based on rate control and based on available bit rate to occasionally skip the encoding of a picture, and you have no chance to detect a loss on a timestamp-based mechanism in that situation. I want to also add one other thing, and that is the TL0 pick index mechanism, broadly speaking, in the two payload formats where it is, in the two ideal payload formats where it is specified, also is extended to allow early detection, quick detection of the loss of an individual packet that belongs to a picture through the start and end bits of the first or the last packet of a picture if the picture is coded in more than one packet. And that's something which you also can't do through timestamp. You basically have to wait until your decoder throws up and says this is a non-compliant bit stream. We have not these start and end bits in that thing there yet, but I would suggest to add it.
No, start
as
and
well.
end are in there.
What's it?
Start and end are in there.
They are in there. Okay, in that case, with the start and end bit, TL0 pick index as it is defined, at least for the H.264 SVC payload format, allows for the detection of a corrupted, partly lost TL0 picture index before that picture is being thrown at the decoder, which is a useful thing. Thank you.
Okay, so I agree with all the points about the variable frame rate. I guess the real question is, do people feel like it's mandatory to include TL0 pick index for this extension, or do people feel like the use of it would be not universal enough to always put it mandatory in this extension, and it should have its own extension? That's the key question, I think.
Go ahead.
I don't know whether this is here an IPR scale thing. We have a patent on this thing. We have several patents on this thing. We'll make those patents available under these standard Cisco-like terms. If that's the concern, forget about it. The other cost that I can see there is that it codes 8 bits. And I hope the 8 bits are not the concern. Thank you.
I'm sorry, I couldn't hear the end of it. I hear the kitchen, not you. What was the last part?
This thing has 2 cost factors. One is the risk through the existing patents in this field. I hope we can deal with that through an appropriate declaration, the way Cisco is declaring their stuff. And I don't mean Cisco because you are standing there, but because this is the way how a lot of people declare patents in this organization. We would use the same thing as we have done it before. So if it's an IPR scare, I hope that goes away. The other cost of including that thing is 8 bits, and I hope the 8 bits are not the concern here. Thank you.
Oh, no, the concern was not the 8 bits. The concern was, my concern was not IPR either. I wasn't aware of your IPR on it, but now that I'm aware of it, and now that I'm aware it's royalty free, that's no problem still. No, the concern is really, will people always populate it? So we either want this extension to be relied on or not used.
So in order to populate thing, you have to have one counter that increments by 1 for each picture you code in the base layer until it wraps around, and a thing that just puts that number in that field for each enhancement layer. That's about 5 lines of code. If I would not want to see something like this as an optional negotiated whatever field, right? That doesn't make sense. So either put it in or don't put it in, but it's useful. I mean, it's used in products in ours at least, so it's useful.
So you want to get a sense of whether we should just go ahead and put it in now in this
So
document?
I guess we should probably try to get a sense of the room. Do people think that TL0 should be in or out, or don't care? Anybody object to my taking a hum now? All right, hum to think that we should have TL0 in this document. People who think we should not have TL0 in this document? Yeah, so we had 2 hums in the room, and near silence with, I think, slightly more humming in the, there's 2 hums in the Jabber room, and then I think it sounded like, you know, a faint hum for and silence against. So the room is all saying yes in. The Jabber room is all saying yes in. So probably we should ask on the list, but can you send this question to the list? But
yep.
It sounds like at this point the feeling is, you know, more towards in, but a lot of people don't care.
So that was the only open issue left in the draft, and if anyone doesn't have any other open issues, I think after we close this, we can probably go on to last call.
All right. There's 4 people for having it in the Jabber room. So apparently everybody who cares is in the Jabber room, not here in the room. All right. So Stefan, I believe you're up next.
Okay, so this is about an individual submission by Jonathan, myself, Magnus, and Bo. In Yokohama, we had this side discussion when we were discussing the layer refresh draft that Jonathan remarked that we have a problem that the semantics of full intro requests, of the code control message full intro request, is underspecified in the current document, and we should do something. And we had a little bit of discussion, and the discussion outcome was basically, the meaning should be that when you receive a FIR on any of the RTP, of the RTCP streams that are associated with forward RTP streams where those layers live in, then you should refresh all the, not refresh, but send independent decoder refresh points on all the layers and not only on the one where it was received. And I volunteered to write this down very quickly, and I did. And while doing that, we came across a number of other little issues, which I also added in this draft. So a 2-pager suddenly exploded into a like 10-pager, which is what I want to introduce now. So the overview. The first is the draft does what we promised to do, what I promised to do, and that is really to deal with the underspecified full info request for layered codecs. The second was, while we were doing that, we figured out that it is actually not trivial to identify when this particular semantic of the FIR would be applicable. When do we have actually a layered codec in use? You can't bind that to an RTP payload format or something like that. So we added a section, informative section about that. The third part is, while we were at it, we also took a look on the other 6 existing codec control messages and figure out how they are applicable. Thank you. Next. So first, with respect to the main mission of this draft, when, again, the problem statement is when you are putting individual layers or sublayer sets into individual RTP streams, and you receive an FIR on the RTCP associated with one of those RTP streams. What do? Do you refresh all the layers all in one? And we agreed in Yokohama we do all of them. And to specify that, we choose a certain way in the language of the standard by redefining a few code points, by spinning a few definitions a little bit differently. And we found that that actually clears up the problem quite nicely. So that's the main mission of this draft. And I believe that part of the draft is pretty stable, pretty solid. There's nothing wrong with that, I personally believe. So next slide. Now, the layered codec identification, that has turned out to be having much more gremlins than we thought. So clearly, when you, just because you're signaling that the codec you're using is, for example, H.264 SVC, RC 6190, and that you have more than one layer, more than one RTP stream covering that, or more than one RTP stream in your system setup, that doesn't mean that those things are really used as layers. It could be that they are simulcast streams, right? There's no law that prohibits that. It could even be that one of them is indicated when you look at, say, the picture headers or the parameter sets, that one of them is looking like a base layer and one of them is looking as an enhancement layer, and they are still independent, because in H.264 SVC, for example, you can code a thing that looks from the look of the parameter set like an enhancement layer, but it's still independent. It does never refer to the base layer. It doesn't use interlayer prediction. So you can use that as an independent, completely independent bit stream. And people use that. This is not something exotic, and the reason why they use it is because SVC also has coding tools in it that the standard spec doesn't have, which some people consider beneficial. So so we looked what can be used. The only really clear indication that we found that speaks for the use of a layered codec is when it's explicitly signaled using SDP and RFC 5538, I think, is it? 5583. We also thought that if someone signaled simulcasting through the new simulcast drafts, that would be an indication that we don't have a layered codec. However, while designing the slides here at this meeting, we figured out that's not the case either. There are more gremlins there, so we will have to go, with respect to that section, a little bit back to the drawing board and rethink it a little bit more.
John Monix is an individual. I believe the simulcast draft does have a way similar to 5583 of saying these are meant to be, dependent layers. So,
Right.
So probably what, would be.
But we still have to write that down.
Right, yes.
The simulcast draft may be fully specifying what should be specified. I hope so. But our draft at the moment doesn't make the correct statement there. So that has to be fixed. Next slide. So with respect to the other codec control messages, I'm racing through those a little bit. There are 1, 2, 3, 4, 5, 6 more in addition to full intro request. The PLI, the SLI, so picture loss indication and slice loss indication are, we believe that we don't have to specify anything to that. And the reason for that is an encoder has enough knowledge when it receives these indications to react appropriately. If it's a smart enough encoder, and we are not specifying how encoders are written to be smart enough. Similarly for the reference picture selection indication, that thing, the new pred backchannel message for those who are in the video coding field, for that is similarly true. And also and then there is the other two, the temporal spatial trade-off request and notification, and that's another open issue to which we come very soon. Next slide, please. So 2 open issues. Number 1 is, or we have now 3 open issues. One is that we have to fix this informative section there. The first real informative open issue is the draft contains language that makes implications about the deployment of these two, of a number of those codec control commands. Basically, it says no one's using SLI, no one's using RPSI, so we don't care what's going on there, and until implementation experience has been reported, we are just ignoring those. Now, we had a similar discussion not all that long ago in conjunction with other drafts. I just want to come back here and reconfirm basically the assumption we had in those other drafts, in the CCM update draft, which has just recently become an RFC, namely that it is appropriate to make those statements, that there's no new information, that someone suddenly is using SLI, for example, and that it's not only that the information that's in the draft is correct, but also that it's appropriate to make that statement. Anyone wants to say something to that?
Mozanetti, I'm not aware of any systems that use SLI or RPSI directly as specified, but like you say, there are technical proprietary equivalents to RPSI that I do know are deployed, and I'm not really sure if that's because RPSI was ambiguous or underspecified or thought to imply the 263 kind of RPSI, but there are systems that I'm aware of that use long-term reference frame management, and frame selection based on.
But they are not using RPSI over RTCP.
No, not using the
That's the
RTCP
point.
messages.
And are they doing this in the context of a layered codec?
Yes.
The language for the SLI is not really strong. It says there's little implementation. It doesn't say that it's not used or anything, or nothing wrong with that.
I didn't say there's anything wrong with it. I just want to know whether you guys are happy with me writing this. If there were something wrong with it, I wouldn't have written it. At least not consciously. Okay, so I will leave that in for now. Yeah, you can bash it up at working group last call later. Okay, next slide. Now, this is something when I read when I sent the draft to a few people who were somewhat interested in this whole idea, That's feedback which I received. And this has a little bit to do with the commercial realities in the video conferencing market that some companies like layered codings and others do not. The tester TSTR codec control message is basically a lot of video conferencing systems have in the user interface a slider where a user can select, I prefer high frame rate vis-a-vis I prefer good quality. So, and the value of that slider is basically communicated using the TSTR request over to the encoder on the other side. The encoder on the other side either honors it or doesn't. But if it honors it, it can say, okay, I am changing my operation mode to favor, as you requested, the quality towards higher frame rate rather than higher SNR quality, higher picture quality, and then can send that back, and the system where the user has just adjusted the slider can, for example, use that to move the slider back, yeah, basically saying, giving some feedback about whether this request was honored or not. That's what it is for, and nothing beyond that, right? There's nothing smart or anything behind it. It's just a way how to communicate a user preference. Now, this thing comes originally from way back when 323 systems. It actually has seen deployment in those systems for sure. I don't know whether a lot of people are using it in zip-based systems, but conceivably they do. Now, when you have a non-layered codec, the reaction to this is pretty clear. When you have just an encoder which is doing something, well, when you want to favor the frame rate, you pull down the QP and then you have more bits available to spend them on more pictures within your constraints of your camera and within the cycle constraints of your machine and all that, right? When you have a layered codec, especially when the layering structure is a little bit more complex, then you have a lot of more options, right? So one option is, of course, you could still instruct the encoder to do something super smart. But on the other hand, you can also just take this input as, okay, let's start throwing away layers, right? It's an option, an implementation option. So I think the outcome, I had some language there in the beginning that suggests that this latter course of action is maybe a good idea, blah, blah, blah. People convinced me at least that this is probably going a little bit too far. And the language we have now in there basically says, we don't know what people are doing. So we don't really say what happens if you receive one of these TSDR requests for one layer, but not for the others. We really don't know what's the right thing to do. So please holler, let us know, let the community, let the IETF know if you have an idea, and until then, treat this thing as undefined. And the draft contains a little bit of information what the sensible reaction is to this undefined information. Yeah. So, for example, when you receive such a request, don't respond. Yeah. When you receive the request, do not send a notification back and stuff like that. So I think those people who were a little bit worried about what there was before were happy with this solution. And again, to the larger group, any feedback?
Mo again, same comment again as RPSI. I'm aware of systems that do a proprietary version of 3060 Hertz selection. It's not using RTCP TSTR, so no guidance on that will bear on those systems. But even more strangely is that it's not even tied to a receiver request. It's not a receiver saying I prefer lower frame rate or higher resolution or higher frame rate. It's on the sending system that it has to have camera and lighting and capabilities that are optimized for one or the other, and the system itself makes a decision or under user control, and it's binary. It's not a range of 0 to 30 or something. It's binary. Do you optimize for 30 hertz or do you optimize for 60 hertz? I think that's common across a lot of vendors. I don't think we're unique in that regard.
I agree. Yeah, that is. Although I'm not sure that I would call this. I'm not sure that if I were implementing that form of signaling in one of the various standardized ways you can signal it today, that the tester-testen mechanism would be the correct one. I think this ought to be a re-invite or something like this. This is something much harder. What you describe is something much harder than a mere user interface based. And clearly, even the quality control command RFC 5538 specifically says don't use it for that purpose which you were just describing, right? So that's something else. Okay, so no one has a problem with it. I leave it in the draft. Okay, next slide. Well, please accept this as a working group item. Normally, I would have said, if we wouldn't have discovered this bug, we could go record time from working group item to working group last call in the same email announce message. But now that we have identified that little bug there, I think we need one more iteration minimum to fix that. Good, then thank you very much.
So I guess since I'm a co-author on this, even though Stefan did all the work, you should do the calls for it.
I didn't do all the work. If I did all the work, it would be cool.
So I call user working group think we should take it as a new work item. Please now. If people do not think we should take it as a working group item, please have now. So I think it was
very quiet both ways, but
Mo, again, I'd like to maybe make a comment that may make it louder. To me, this is trying to remove some of the cruft that's lingered around for a long time, that's kind of unused. I'm all for removing the junk that people are not actually using, and we don't have to keep specifying it in every new payload format. How does it interact with this feedback message and this feedback? We can deprecate feedback messages that people are never using. It's good for future payload formats. So hum if you support simplicity.
That goes a little bit beyond the scope we have at the moment. So if, okay, we just we just refed this darn codec control stuff, right? And come on, we just refed it. It's not that there wasn't an option to discuss this removing that graft, as you call it, about a year ago.
But like all the payload formats that come up, we have to address all the different feedback messages that are relevant.
If I were to, or hopefully I will be writing video payload formats, what I would do with SLI is do not use it, period. One sentence, right? It's not that hard.
The more we can say don't use it, the better.
So we also had 2 comments on the Jabber room saying to adopt, so.
Just a question on why did you consider to do an update to RC 5104? To do a BISDRAF on that instead of having it as a separate document?
I mean, I think it's. I would say I wouldn't say. I don't think we want to actually write a BISDRAF. I'd say this would be has updates 5104.
No, currently it's an update to. I was just asking if that
I don't
was
think we
not.
want to open up the can of worms. That's actually a 5104 BIS, unless people disagree. I mean, personally, as an individual, I think I don't want to do that work.
It's not only 5104. It's also 5583.
All right. I think it'd be more,
No.
Actually, I think this is just 5583, isn't it? These are all CCM messages.
Clean that up once we know a little bit more.
Yeah. Yes. Yeah. I'd say. I guess this is actually just touching 5583, right? Not 5104.
So, my recollection is 5104 we just refed. 5583 we didn't.
Right.
This tester stuff, for example, lives in 5583. FIR lives also in 5583.
Right. PLI.
SLI and PLI lives in 5104, and that's why I said we just refed this. There was ample opportunity to remove it. We didn't do it. We,
Yeah, I mean,
whether that was a good or
yeah, I
bad
mean,
decision, different story, but
yeah.
we did.
I mean, I think all the things in which, yeah, but I think all the things, oh, that's, no, FIR is in 55A3 is a CCM, right?
My recollection is the congestion control police didn't allow us in 5104 to put FIR in, but a little bit later we wore them down sufficiently that they allowed us to put it into 5538. That's my vague recollection.
I mean, so I think all the things in which this actually has normative guidance is in 5538, right? Yeah, no, is it? Oh, you're right. Okay, well, okay. If FIR is in 5104, then this updates at 5104. And I think it's just updates 5104. I mean, because the only thing FIR is the only one we're actually issuing new normative guidance on, right? In this document, everything else is commentary.
FIR is hard code, independent decoder refresh, no other change.
No. What I'm saying is, FIR is the only message which this document actually gives normative guidance on, as opposed to commentary of we don't know what this means. I think.
I think so too. Yes.
Okay, then this would just update 5104 if that's where FIR is. Yeah, Varun confirms FIR is 5104. This document we mark as updates 5104. I think was the conclusion. Oh yeah, so I think we have.
We have just the
We'll have to
list.
ask on the list, but it sounds like, I mean, I'll let Rachel tell me if she disagrees because I'm a co-author, but it sounded to me like we had, mostly don't care, but for people who cared, everyone thought that we should adopt this as a working group item.
This is Ben. I think the acoustics and background noise were working against you. I think there was more than you think you heard.
Okay.
And other people may disagree. I didn't hear a loud hum, but I heard hums from around me.
Okay, but all four and none against?
I did not hear any against.
Okay, well, the AD sounds like we have all four, none against, so it sounds like we have agreement. So I'll write up I'll work with Ben to set up a milestone, and then we'll adopt this as a working group item subject to confirmation on the list. And I guess Rachel should send that email because I am.
Sure.
Yeah.
Okay.
All right. I think that's our last presentation. The final item on our agenda is open mic. Any other issues? Anybody have anything to say? Otherwise, see you in Berlin and enjoy bits and bytes and/or dinner.